everyone, welcome to this lesson. Today we're going to be talking about the basics of confidence intervals. We're about to start our journey into inferential statistics, which is the branch of statistics that uses statistics to provide estimates of unknown parameters. We're going to be using confidence intervals to estimate an unknown parameter. For now, we're going to focus on the basics of confidence intervals. Your goal for this lesson is to be able to define key concepts related to confidence intervals, such as point estimate, confidence level, significance level, and margin of error. Another goal for this lesson is to be able to interpret a confidence interval using the context of the situation. So if I give you a confidence interval, can you tell me what it represents? Can you use the context of the situation to explain someone what the confidence interval is telling us? Let's go ahead and get started. Again, recall that inferential statistics is the branch that uses statistics to provide estimates of unknown parameters. Let me give you an example. You can use X bar, a sample mean, to estimate mu, which is the mean of the population. Let me give you another example. You can use a proportion coming from a sample. We denote this as p hat. This is a sample proportion. You can use this to estimate p, which is the proportion coming from the population. Okay? So that is what we're saying here. We can use statistics to estimate unknown parameters. Why do we do this? Because in most cases, it is almost impossible to study the whole population. It's impossible to study the whole population to find mu, to find p. That is why we use X bar and p hat to estimate those parameters. So that is the idea here. Now let's talk about what a point estimate is. A point estimate is a single value that estimates a population parameter. Let me give you the same two examples that I give you above. X bar is considered to be the point estimate of mu. P hat is considered to be the point estimate of p. We can use a point estimate to estimate a population parameter. Now, let me show you an example that can help you see why we might want to use a confidence interval instead of using a point estimate. Let's assume that we want to know the mean placement test score for students at a community college. Here, in other words, we want to know mu. This is the mean coming from the whole population, from all students at community colleges. Assume we randomly selected a sample of 6,000 students. We found that the sample mean score is 72. Here, we have X bar, the sample mean. We found that to be 72. Now, what is the point estimate? The point estimate here is the sample mean. That is X bar equal to 72. You're going to use this point estimate to estimate something. What are you trying to estimate? Here, we're trying to estimate the population mean. Let's make a remark. We denote the population mean as mu. Again, mu would be the mean placement test, so the mean coming from all students at community college. Now, what if we go and report that the population mean, mu, is X bar equal to 72? How confident are we that the mean test score for all students, again, the population mean, is exactly 72? We're not that confident, right? What if the population mean is something like 75 or 73? What if we're off? We're not very sure that the population mean is exactly 72. Okay? So let's just write, we're not that confident. We're just going to write, we're not very confident. Let's add that it's possible that the population mean is not exactly 72%. Here in part C, we would be trying to estimate the population mean with a point estimate. Let's make a note here. Using a point estimate is like fishing with a spear. We are probably not going to capture the mean. We are likely to miss. Now, what if we go and report that the mean test score for all students is between 62% and 82%? How confident are you that the population mean is between 62% and 82%. I mean, we're not going to say that we're 100% confident that the population mean is between 62% and 82%, but we are more confident than before when we were using the point estimate. So let's go ahead and write, we are a little bit more confident. We are more likely to capture the population mean if we give ourselves some room for error, right? If we give a range of values, that is, if we use a confidence interval. We're going to write, we're more likely to capture the population mean if we use the interval, and I'm going to say the interval using interval notation. We're including all values between 62 and 82. Again, here we're saying we think that the population mean is between 62 and 82. Now, let me make a final note here. Using the interval is like fishing with a net. It is more likely that we're going to capture the mean using an interval. And so this is the reason why we're moving away from relying on a point estimate to estimate a parameter. We're moving towards creating an interval that can capture that parameter. So let's talk about confidence intervals. A confidence interval is going to be a range of reasonable values which we expect the population parameter to fall. So when you think about an interval, you should be thinking of a range of values. When we create this interval, we're going to have a level of confidence. This is usually expressed as a percentage, and this is going to be the percent that describes how confident we are that the interval captures the parameter. Now, keep in mind that there's no guarantee that the given confidence interval does capture the parameter. We might miss, okay? However, we're going to have a predictable probability of success. This is what we call the confidence level. Before you construct a confidence interval, you need to decide what confidence level you want to use. In this class, when I ask you to construct a confidence interval, I'm going to tell you what confidence level to use. So here on the right, I have an image to help you visualize this idea. In this image, you see that we're trying to capture mu. Mu here is at the center of our image. Here, we don't know the value of mu. However, I can go and take a sample from the population. I can find X bar, a point estimate, and I can build a confidence interval around this point estimate. Okay? So here, the first horizontal line that you see, you can think of this as a confidence interval that I created. The image shows that my confidence interval did capture the population mean. Now, we can repeat this infinite number of times. Let's say that you go and take a sample from the population, okay, and you find X bar for that sample. You can construct a confidence interval around this X bar. Let's say that your confidence interval is the second horizontal line that we see here. Notice, according to this image, your confidence interval did capture the population mean. And again, we can have someone else go and take a sample, calculate the sample mean, and build a confidence interval around the sample mean. Now, it could be the case that somebody else does the same thing. They come back with a confidence interval, and their confidence interval does not capture the population mean. So be aware that there's no guarantee that the confidence interval you found does capture the parameter. There's going to be a percentage of confidence intervals that do not capture the parameter, and there's going to be a percentage of intervals that do capture the parameter. Okay? So this takes me to, let's talk about those percentages. As I mentioned before, the confidence level is going to be the probability of success. Okay? So the value, you can think of the confidence level being the probability of success and the significance level being the probability of failure. Okay? So let's talk about these in detail. The value of the confidence level, which is denoted as CL, which stands for confidence level, is going to be the proportion of intervals that contain the true population parameter when repeated samples are taken. The most common confidence levels are 0.90, 0.95, and 0.99. And so, for example, if you tell me that your confidence level is 0.90, then I'm thinking if repeated samples are taken and you calculate the sample mean and you construct a confidence interval, then I know that 90%, right, 0.90 represents 90%. So I know 90% of all those confidence intervals are going to capture the population mean. So again, the confidence level is going to tell you the proportion of intervals that do capture the true population parameter. Now, let's talk about the significance level. The significance level, which is denoted using the Greek letter alpha. Let me go ahead and write alpha. Now, this Greek letter alpha is going to be the proportion of confidence intervals that do not contain the true population parameter. Now, here I should add when repeated samples are taken. We're not just talking about one interval. We're saying if you go ahead and repeatedly take samples from the population, you find the mean and you find confidence intervals with those means, then the significance level is going to be the proportion of confidence intervals that do not capture the population parameter. Thus, alpha is equal to 1 minus the confidence level. The most common significant levels are going to be related to the common confidence levels. These are going to be 0.10, 0.05, and 0.01. These significance levels are determined by the confidence level. Why? Because alpha is equal to 1 minus the confidence level. So, for example, if your confidence level is 0.90, then 1 minus 0.90 is 0.10. If your confidence level is 0.95, then alpha is going to be 1 minus 0.95, which is 0.05. And finally, if your confidence level is 0.99, then alpha is 1 minus 0.99, which is 0.01. Now, let's look at an example where you're being asked to interpret the confidence interval, to interpret the value of the confidence level, and to interpret the significance level. If you're able to interpret those, then you're showing me that you know what they are and you know what they represent. A fitness center found a 95% confidence level for the mean number of days per week that Americans who are members of the fitness club go to their fitness center. Here we have the confidence level expressed as a percentage. Most of the time we write this percentage as a proportion. So we would write the confidence level is equal to 0.95. We see that a fitness center is constructing a confidence interval. They want to estimate the mean number of days per week, which is going to be mu. This mu is coming from looking at all Americans who are members of the fitness club and go to their fitness center. Now, records of 276 members were looked at and their mean number of visits per week was 3.5 and the standard deviation was 2.7. Okay. So here, we're seeing that they're taking a sample, so n is equal to 276. They found the mean for this sample, so they found x bar, which is 3.5, and they found the standard deviation for this sample, which is s equal to 2.7. Now, they're saying that they calculated this confidence interval. In simple words, the fitness center is claiming that mu, the population mean, is between 3.18 and 3.82. Okay. Now, whenever you're asked to interpret the confidence interval, you need to use the context of the situation. The first thing you want to include is the confidence level. Okay? We're going to write, we are 95% confident. We are starting by stating our confidence. We are 95% confident that the mean number of days per week American members of the fitness club attend their fitness center is between, and this is where we're going to say the confidence interval, but we're just going to say in between 3.18 and 3.82 days per week. So notice, here I'm simply saying we are 95% confident that mu is in between 3.18 and 3.82. But again, when you interpret the confidence interval, you need to use the context of the situation. You cannot just write mu. You need to explain in words what mu represents. Now, how would you interpret the value of the confidence level? In this case, the confidence level is 95%. You can also write this as a proportion, which is 0.95. How would you interpret this confidence level? What about the significance level? 5%, which can also be written as 0.05. I'm going to include 2 multiple choice questions below this video. You're going to select the best interpretation of these values. These questions are going to be multiple choice questions so that you have a detailed sentence explaining each of those values.